Good morning, good afternoon, and good evening, everyone. So today we're going to be talking about um, my extended question in my population dynamics write-up. So for this extended question, well, in most logistic growth models, the environment supports a fixed population size called the carrying capacity. But in real life, like with climate change or urban overdevelopment, the environment can worsen, and so the carrying capacity may shrink over time. And so my question basically is, bottom line, what happens if my population growth, or what happens to my population growth if my carrying capacity decreases steadily over time? Right? And so the standard logistic model, so this was based on the write-up. So based on the write-up, the standard logistic model is actually just dy over dt, which is equal to ry, 1 minus r divided by k. So in the initial um, model, it was supposed to be that the carrying capacity is constant. Here, notice how I'm using the same logistic model, standard logistic model, but instead of it being a constant, now it's a function because my carrying capacity is also moving or it's decreasing, right? So that's the standard logistic model. But what if we make the carrying capacity as some function of time, right? Well, if we do that, well, then now it becomes some k of t, which is something like this, right? Well, then our new model becomes as follows. So dy over dt, ry, 1 minus y over my k of t, right? Well, and then from there, this makes the system non-autonomous, right? What do we mean by non-autonomous? Well, meaning its behavior changes. So the behavior of that system changes over time, even if the population size stays constant. So even if I were to make my population size constant, well, my carrying capacity will still, so everyone will still die. I'm kidding. Everyone will still, yeah, the carrying capacity will still decrease, right? And so here's the initial work. So we observe that at t equals 0, then we have my carrying capacity as 5,000, right? And so my population behaves like a normal logistic model and grows, right? So it's just a normal logistic model, and it's growing until it reaches that carrying capacity, right? Okay. However, once we reach a certain time, so let's say at t equals 50, well, then now my carrying capacity is 2,500, right? I just multiply t here, I get 2,500 as my k. And so, if the population hasn't slowed, it may exceed the new carrying capacity and start declining. And then another observation we got was when t is now 100, well, now my k is 0. And so the environment can no longer sustain life, right? Um, so the idea is that initially the population grows, then the growth slows down as k of t decreases, and eventually the population hits a maximum, and then it declines, right? And so, well, if we plot this with numerical approximation, it will likely form a hump-shaped curve, growth, peak, and then collapse, right? So, okay. Uh, So personally, I can't solve this using separable differential equations. I can do it with that. Um, so I think the best way to do this, well, mm, I could do Euler's method, or something else, or just plot it in Desmos in Python. So I could do that. Uh, yeah, I don't think we can, because unlike this other one, where we were able to kind of separate it, or even this one actually, and then this just becomes y over k. I mean, I think it's complicated to do it here, in my opinion. Um, mm, so yeah, um, how might I solve it? Well, yeah, here we can see that the equation, I think, yeah, it's not, mm, or it would be hard to solve it analytically. So getting an exact answer, right, through separation because of the time-dependent denominator, right? So that's one of the reasons why. Um, and so based on Google, I might just go with something else. Um, so here's what Google said. For AI overview. Probably just do Euler's method or this. So yeah, basically I have to learn how to do or how to use numerical methods for this. It's either that, um, Yeah, because I don't think we can solve this analytically. Yeah. And then what else can I say? I guess yeah, just to wrap it off, I guess like other questions to ask. Or I think I could just learn Euler's method now. It's a numerical technique for approximating solutions to ordinary differential equations. Mm, maybe I don't know how to do this yet. Oh, yeah. I mean, I'm not like super sure. Anyways, yeah, I can't learn Euler's method right now. I'm not taking any classes for it. Uh, so maybe like other questions to ask is, do you think shrinking capacity is more realistic? So what if the capacity was shrinking rather than just constant decay? Or then linearly decreasing capacity? I guess another question to ask is, well, what real world examples could this model represent? Or no, actually not that. Because I already know there are real world examples. Just for like discussions, would it be better to make, say, my k decay exponentially instead of linearly? Wait, I think I just did the same thing here. Shrinking capacity is more realistic than constant growth limits. I don't understand this question. Yeah, I'll just stick to the to this one. Oops. Okay. Uh, let me also get my other questions. I mean, I have more like follow-up questions here. Yeah, I think I'll just leave it this way. Um, don't really know what else I can do. I mean, yeah, that's I think yeah, that's pretty much it. Um, I'm trying to like think. Yeah, because I'm trying to get like a Desmos generated graph, but I can't seem to get that one. Um, yeah. Um, I'm gonna show you actually guys a really quick visualization of the code of how that would kind of look like. So if I run this, let me see if I'm showing the right screen. I'm showing the right screen. Oh, there. Yeah. So the population is this blue curve where it kind of grows at first, and then it kind of reaches its peak here, and then it starts collapsing, right? Here my x, okay, I don't know how to change this because GPT did this for me. My x is basically the time, and then my y is the number of people, right? And so this is also my um yeah, so that's my carrying capacity. Then once it goes down, they intersect. Well, that's when my population starts collapsing. Yeah, I mean, nothing really else to ask here. Um, yeah, pretty much that's, yeah, I mean, that's pretty much it, I guess. But there are some like analysis that we could do here. which I think would be pretty interesting if we just ask more questions. But yeah, that's pretty much the idea behind it. I hope you guys enjoyed and learned something. And yeah, I'll see you guys all in the next one.